So we have our parabola opening upward, move down 1, and that's what we have here in this curved parabola right here. Our y equals -1, and that's our horizontal line here at a height of -1. Our x equals 2, that's our vertical line right here over at 2. We're taking a look at that area, which is this kind of curved triangle here. Let's go ahead and shade that. So I went ahead and shaded that. I also went ahead and got rid of the graph that we don't need, so we can just kind of focus on our shaded region that we're revolving around our y equals -2. Since it's a horizontal axis of revolution, once again we're dealing with x. So then we got to look at where horizontally the x's do we intersect at. We intersect at 0 here. And we intersect over here at 2. Then we got to go ahead and we realize, hey, we have a hole. After we revolve this, we'll have a hole in the middle. So we need to eliminate that hole. So we need to look at the outer radius squared. The outer radius squared, which would go from here down to here. In this case, it's what's on top minus what's on the bottom. Again, what's on top in this case is our curved parabola minus what's on the bottom, which is our -2. So we got to go a curved parabola minus our axis of revolution of -2. Then we got to go ahead and look at the inner radius. Inner radius would be this right here. So we got to go what's on top, which is our -1, minus what's on the bottom, which is our axis of revolution of -2. Then we can go ahead and do a little bit of simplifying here because we're really adding 2, which gives us an x squared plus 1, all squared. And then we get a +1 here, all squared, which is just 1. So to work this out, we'd have to FOIL this, combine like terms. The 1's are going to drop, so then we just have to integrate the stuff with the x's, increasing them by 1. Then we got to go ahead and plug in our 2, minus what we get when we plug in 0, which doesn't change it. So we get 176 pi over 15.